Well everyone, let's do excuse me, do an example of finding the equation of a tangent to a trig curve. Okay, so we've done find the equation of a tangent to a curve. Okay, so the structure for that was a point, a gradient and the equation. Knowing the point on the line, find the gradient and find the equation, right? Equation of a straight line. Okay, so we're going to find the equation of a tangent, so touch is at one point, for the sine graph at a particular point. Okay, so what you need for these types of questions is your structure, you need to know your derivatives, you need to know your exact values. Okay, so we're going to just look at it in degrees. Okay, so we'll convert that just now in our head to 60 degrees. Okay, unless you want to work with your radians in here, which is perfectly fine. Okay, so let's have a look at this sine graph at 60 degrees. Okay, so a sine graph at 60 degrees. Okay, our value, our output, right, we should know from our exact value table. Okay, okay, so sine of 60, okay, 60 opposite hypotenuse. Okay, so that will automatically tell us the point on the line. Okay, point on the line, point on the curve is 60 root 3 over 2. Okay, right. Okay, so if I've got a point on the line, right, the point meets the tangent, so the line meets the tangent, 1 point. Okay, the gradient. Okay, so the gradient, let's go through what we would need to know, right? For the gradient, well, if we had two coordinate points that we've done National 5, we could use that. Okay, if that's not working, do we have an angle? Right? Do we have that angle? That tangent, right? So this is a tangent line here. Right, this is the equation we're trying to find. Sorry, I should have shared that with you. That's the equation we're trying to find, right? Let's call it line 1. Okay, that is what we are trying to find. Do we know that angle? Right, do we know that angle? We don't know that angle. Okay? It's interchangeable all the way along that curve. So, our other option that we need to be thinking about is our derivative. Okay? Right, so thinking through 2 points, that's really National 5 or straight line, a bit higher, straight line for tan theta, everything else, curves, thinking differentiation. Okay, so our derivative of sine x, so if we have sine x, our derivative is cosine x. Right, but what is the gradient? The gradient is the value at that particular point. So it's that cosine of 60. Okay, pi by 3. Right, so cosine of 60, over here exact value table or exact value triangle. Okay, you might be using this here. Okay, so you're looking for cosine of 60, a over h. Right, so it's a half. So the gradient, which is equivalent to the change in rate, which is equivalent to the derivative at a particular point, is a half. Okay. And an equation with a tangent, here is a straight line, y minus b m times x minus a. So y minus value b root 3 over 2, gradient half x minus, now we're thinking degrees, don't insert 60 degrees there, pi by 3, okay? Right, don't change the unit of measure, okay? So multiplying through by 2, okay, you'll not need to write that, you'll be thinking that now, but if you do, you're more than welcome. 2y, root 3 over 2 multiplying by 2, 1 multiplying x, 1 multiplying negative pi by 3, and then you're tidying it up. Okay. Now, thinking back to straight line, these two values you would add together normally because they're whole numbers or integers, at least. So I would just stick to the same rules, get all your equations equal to 0, okay? But really, that is it simplified, because you're not going to add pi by 3 onto root 3 or otherwise, okay? You're just going to probably leave it at that point, okay? But that's an equation of the tangent at pi by 3 for the curve y equals sine x. Okay, so you see there's various similarities between what you've done before. There's just a wee bit more work needing done, okay? If you only have the x value, you have to find the y value by using your original strategies for gradient and putting into your straight line, simplifying, underlining your answer, okay?